Dear students, in this lecture we will discuss functions. As we already discussed Cartesian product of two sets and then relations. We have seen that relations are subset of Cartesian product. And now we will move towards functions. First we write the definition. A relation f from non-empty set A to non-empty set B is called a function for every x belongs to capital A, there exists unique y belongs to B such that x y pair belongs to F. So, means the elements of function are also ordered pairs. Thus, what we get? Thus, function f is a non-empty subset of Cartesian product A and B such that every element of A appears in some ordered pair of F and no two ordered pairs in F have the same first elements. Now, to understand this, first let us have some examples. This is all the theory part, theoretical definition. To understand, we will discuss some numericals. Okay, let us have two sets. We have let us have a F set having elements 1A, 2B, 3C. So, clearly this is a subset if A is 1, 2, 3 and B is A, B, C. If these are the two sets, then we have their Cartesian product, then we have written the relation. Now, we have taken the subset of a relation, ultimately it is a subset of Cartesian product. Now, how can we express relations by arrow diagrams? We draw that diagram first. This is A, this is B, A, B, 1, 2, 3, A, B, C. Now, as you see, 1 goes to A, 2 goes to B and 3 goes to C. So, this is a simple example of a function. So, here f is a function. Now, why? So, we will discuss now these two definitions again. For every x in A, there exists a unique y कि इसके हर एक एलिमेंट के लिए यहाँ पर एक यूनिक एलिमेंट है. और by in second part we have written every element of A appears in some ordered pair of F and no two ordered pairs have same first element, that none of these have same first element. So, this is a function. Now, let us have another example. Now, let f is, we will just generalize this again, 1 goes to A and 1 goes to B, 2 goes to B and 3 goes to C. So again drawing the arrow diagrams, this is A, this is B, this is A, this is B. Now 1, 2, 3, A, B, C. Now you see 1 goes to A and 1 goes to B. 2 goes to B as well as 3 goes to C. Now just try to understand that 1 has not unique image. 1 is going to A as well as going to B, and also here the first element appears twice. So here this is not a function. This is not a function. One more thing we will clear from here, that see, either 1 is going to B, 2 is going to B, it's okay. 1 has a image B, 2 has image B, it's okay. But 2 can't have 2 images as 1 have. So if only 2 elements are going to be, it's okay. So we will have example for this also. Let us write F again. 1 goes to A, 2A and 3C. So again we draw this. This is A, this is B, 1, 2, 3, A, B, C. So 1 goes to A and 2 goes to A, 3 goes to C. Now, so as per our discussion, is this a function? Yes, this is a function. 1 has an element A, 2 has an element A. It's okay. Just try to understand this, that both are going to a unique element and 3 going to C. This is also a function. Okay. Now we will have some forms of the function. So generally functions are denoted by this symbol, arrow B. So this denotes function from A to B. Now we will discuss what are real functions and real valued function. If both A and B are subsets of R, then they are called real functions. And if only B is contained in R, it is called real valued function. It is called real valued function. Okay, next important thing, domain, codomain and range of a function. Now again we start with a function f from A to B. Now here clearly A is called domain and B is called codomain. Then what is ranges? Range is all the images of F under A. All the images under F of A. For example, if we have this example, let us have this example. You see, in this example, what is domain? 1, 2, 3. And what is range? Ranges, images are A and C. Range is A and C. So we just try to write this example. I am discussing this example. This is number 1, number 2, number 3. In example 3, domain is 1, 2, 3. Codomain we write first. codomain, as we discussed, the whole set B, that is A, B, C. And range, the images, see the only images for 1, 2, 3 are A and C. So range is A and C itself. So this is how we can have the domain, codomain and range of the functions. Now how we represent functions? So here in mathematics, functions are represented by two forms. One is ruler form, or another is and graphical form. Rule form means we just write that a function is represented by, let us have a constant function. So in ruler form, how we express constant function is expressed as x fx, where x belongs to R. And for constant function, what is fx? That is fixed. If it is c, then it is c. X for all real numbers, its value remains c. So this is rule form. We write the rule which it is going to satisfy. In graphical form, first we check the elements of this. This is x and this is fx. You see, x is a real number. Let us have 1, 2, 3, 4, 5 and so on. So what is the value of fx? If fx is c, it is c, 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 c for all values, Then what is the graph of this? Let us try to plot this graph. This is our x-axis and this is second axis, y-axis, and here y is fx, which is a constant function, constant c. And you know, this is a positive axis, 1, 2, 3, so on, negative, minus 1, minus 2, minus 3, so on, and 1, 2, 3, minus 1, minus 2, minus 3. You see, whatever the value of this domain is, x is, we will get a constant function c. If c is 3, let it be 3. For all values of x, this will remain 3. So this be the plot for a constant function for c is equal to 3. Now what will happen when this c is negative? Then this will line will cross the axis and will be here. And what will happen when c is 0? For c 0, then this line lies on x-axis. For every x, function value is 0. Some more real functions. Next is identity function. F is from R to R, and we all know identity function means fx is equal to x for all x belongs to real numbers. So you see, what is domain of this function? Domain is R. And what is range? See, whatever we are inputting, the same we are getting as output. So range is also R. So how is the plot of this function? So if we try to make its table, x and fx. If we put input 1, we will get 1. If we input 2, we will get 2. If we input 3, we will get 3. So for all numbers, for all real numbers, we will get the same output. You will see, so it will look like this. This is x-axis and this is fx. This is origin. So this is the graph of identity function. Okay, next function, modulus. function. So, we denote modulus function by R to R. Here fx is given by, so this is the symbol of modulus. So, modulus means, so it will remain always positive. If x is positive greater than or equal to 0, output is x, but if x is strictly less than 0, output is minus x. So, here this is a this is a magic box where we are inputting positive value, we will get positive value, but if we input negative value, we will get again its positive value. How it becomes positive? We just multiply this number by minus sign. So, what will be the domain and range here? Domain is any real numbers. What about range? You will see in the range part we are only getting positive numbers, only the positive real numbers. So, range is 0 to infinity, all the positive real numbers. So, its plot will look like, its graph will look like this. This is x, this is fx, and its table will look like x fx, that is mod of x. If we input 1, we will get 1, but if we input minus 1, we will again get 1. If we input 2, we will get 2. If we input minus 2, answer is again 2. So, how it look like? For positive numbers, it will behave like identity. But what for negative numbers? For positive numbers, it will behave like identity. They remain same. For 1, it is 1. For 2, it is 2. For 3, it is 3. What about negative numbers? For negative numbers, it will behave like positive number. So, for negative number also, the value for minus 1, we are getting 1. For minus 2, we are getting 2. So, it is like this. So, this is the plot of modulus function. Okay, next function is Signum function. So, it will look like fx is mod x by x for x not 0, 0 for x 0. So, another form is 1 0 minus 1 for x positive, for x 0, for x negative. What is domain here? As in all, it is again set of real numbers. What about range? You just have a look. We are getting only the 3 elements as output. So, range is minus 1, 0, 1. And what is the plot of this function? The plot will look like this. So, before going to plot, we just try to make it stable, x and fx. For x positive, let it be 2. What is fx? 1. For x 0, it is 0. For x minus 2, it is minus 1. So, we only have 3 values. For all values positive, it will remain 1. If this is 1, it will remain 1. And for all negative values, it will remain minus 1. So, this is the plot of, this is 0 1, 0 minus 1. It will remain this. Okay, next function, we just draw a line here, make it separate. Okay, greatest integer function. So, it will look like, again f is from R to R, fx has of the form square bracket of x. This is greatest integer function. So its definition is greatest integer function denotes greatest integer less than or equal to x. So this is the value of greatest integer function. For example, if here we make a table x and fx. Fx is greatest integer of x. If we put 2, 2 is already an integer, greatest integer of 2 is 3. 0, 0 greatest integer is 0. What about 2.1? 2.1, the greatest integer is, on the left is 2. 2.7, greatest integer towards left is 2 itself. But what about minus 2.5? Minus 2.5. Now here the greatest integer is minus 3. How we get minus 3? To understand this, we will draw a real line. Let this be a real line. This is origin. This is 1. This is 2. This is 1. This minus 1, minus 2, and somewhere here it is minus 3. You see, for 2, its value is 2. For 0, its value is 0. For 2.1, 2.1 lies somewhere here. If this is 3, this is 2.1. Then the integer toward left is 2 itself. If it is 2.7, again the integer towards left is 2 only. But for negative numbers, if we take minus 2.5, what is the integer towards left? Towards left. Now it is minus 3. So that's why we are getting minus 3 here. Now from here, what is domain? Domain is all real numbers. What about range? Range is set of integers. We are getting integral values only. And its graph will look like, this is x, this is y. So its graph will look like, so for this we need to draw number 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. You see, what will be the value between 0 to 1? Between 0 to 1, integer toward left is 0 only, so it will remain here only. Okay, between 1 and 2, so at 1 its value is 1, and up to 2 its value will remain 1, and at 2 its value is 2, and up to 3 its value will remain 3. For all numbers between 2 and 3 its value will remain 2. And similarly for negative numbers, from, now you see, from minus 1 to 0, how much is the value? It is minus 1. And from minus 1 to minus 2, its value is minus 2. So this is how the graph will look like. Okay, next function, polynomial. Again, let f is from R to R. So we'll let an example, if fx is written by x square. You see, what is the graph for this? What are the values we get here? X and fx. If we input 1, we will get 1, 2, 2 square, 4, 3, 9. And what about negative numbers? Minus 2, 4, minus 3, 9. So what is domain? Real numbers. And how the plot will look like? This is x, this is y. You see, the plot will look like, at origin it is 0, at 1 it is 1, at 2 it is 4, at 3 it is 9. And similarly here, for minus 1 it is 1, for minus 2 it's 4, for minus 3 it is 9. So it will look like this. it will look like this. This is the region. Now, next plot is plot of exponential function e power x. So, here we just have an idea of exponential function. So, the plot is like this. This is x and this is y. This is 0, 1. Y is equal to e power x. And for logarithmic functions, plot will look like this, and this point is 1, 0. Y is equal to log x. This is x, this is y. This is y is equal to e power x. This is for y is equal to log x. Let's have some numericals now. A is equal to 1, 2, 3, 4. B is equal to 1, 6, 8, 11, 15. And we are given a set A to B denoted by F1 is 1, F2 is 6, F3 is 8, F4 is 8. So, we have to check whether these are this is a function or not. If not, we have to justify. So, the easiest method is to have an arrow diagram. This is A, this is B. A is 1, 2, 3, 4. B is 1, 6, 8, 11, 15. So, as per given, 1 goes to 1, 2 goes to 6, 3 goes to 8, and 4 goes to 8. So, you see, is it a function? Yes, because here every element of A goes to a unique element. So, this is a function. Next example, let us have F1 is 1, F2 is 6, F3 is 6, and F4 is 15. Now, is it a function? F1 is 1, F2 is 6, F4 is 15. So, just have a diagram, small diagram, A and B. 1, 2, 3, 4. 1, 6, 8, 11, 15. So, 1 goes to 1, 3 goes to 6, 4 goes to 15. So, here 1, 3 and 4 have unique images, but 2 don't have any image. So, in this definition we have learned every element has a unique image. Okay? Every element goes to a unique element. So, 2 is not going anywhere. So, this is not a function, not a function. Let us now discuss some more numericals on functions. Here f is a set having ordered pairs, be a function from z to z, integers to integer, defined by fx is equal to ax plus b. For some ab belong to integers, find ab. Now, how can we find ab? For this, we will make a table of values. This is x and this is fx is equal to ax plus b. What is x here? 1, 2, 0, minus 1. And when we put 1 here, what we get? A plus b. How much is this? 1. When we put 2 here, 2a plus b. How much we get? 3. When we put 0 here, we get b. minus 1, and when we get minus 1 here, minus a plus b is equal to this value minus 3. Now here simply we will get b directly from here, so b is minus 1. Now from first equation we have a plus b is equal to 1, so simplifying a equals to 1 minus b, putting the value of b minus of minus 1, 2. So that means a is equal to 2, b is equal to minus 1 is the required answer. Okay, next question. Let a be a set and f is a function from a to z defined by x square plus 3. Find range and pre-image of 28. So first we find the range of this function. To find the range of this function, first again we make a table of this function. So this is x, and fx is defined by x square plus 3, minus 5, minus 3, minus 1, 0, 1, 3, 5. So when we put minus 5, what we get? 5 square minus 5 square plus 3, that is 25 plus 3 is 28. Minus 3 square plus 3, 12. Minus 1 square plus 3, 4. 0 square plus 3, 3. 1 square plus 3, 4. 3 square plus 3 is 12. 5 square plus 3 is again 28. So here you will easily get the range. So what is the range here? So range of f is 28, 12, 4, 3. So the images that we get here are range. Now pre-image of 28, to find this, so we set x square plus 3 is 28. So we have to find the value of x for which it is getting 28. So you will easily get x square is 28 minus 3, that is x square is 25. So what are the values of x then? So clearly x is 5 minus 5. Next numerical, find the domain for which function fx and gx are equal. And by equal functions we mean the values of functions are equal for all x. So we put fx is equal to 2x square minus 1, gx is equal to 1 minus 3x. And taking all things to left hand side, we get 2x square plus 3x minus 1 equal to 0, which further imply 2x square plus 3x minus 2 equal to 0, to making the factors 2x square. So we want product is minus 4x square, and here we get 3x. So we write it as 4x minus x minus 2 equal to 0. So taking common 2x, x plus 2 minus 1, x plus 2. So making factors 2x minus 1, x plus 2, which further imply either 2x minus 1 equal to 0 or x plus 2 equal to 0, which means either x is 1 by 2 or minus 2. That means domain for which two functions equal are is minus 1 by 2 and plus 1 by 2 and 2. Okay, next question. If fx is 1 upon 1 minus x, show that this holds. Now you see here we have to repeatedly put the value of x in the function. Given fx is 1 upon 1 minus x. At second step, what is f of fx? Means f of, so we put the value of this inner fx, that is 1 upon 1 minus x. Now we just look this as this. In place of x we have this, so just replace this x with this. So we get 1 upon 1 minus 1 upon 1 minus x. So taking LCM, so what we get? Minus 1 minus x upon x. Now again f of fx. So we already calculated this. How much we get this as? Minus 1 minus x upon x. So again putting this x here, this is 1 upon 1 minus, so minus is already there, it becomes plus 1 minus x upon x. Taking LCM, x plus 1 minus x, x cancel, so it becomes here x upon 1 x, which is the required proof, required solution. Okay, next numerical, find the domain of fx. So domain we already discussed many times. Domain is those values for which this is defined, this set is defined, this function is defined. So you see 1 upon x is defined for all values except 0, because 1 upon 0 is not defined to 0. That means domain of function is all real numbers except 0. So this is the domain, all real numbers except 0. Okay, next question, again we have to find the domain. So as we discussed here also a domain is those values for which this function is defined. You see square root is defined for positive values only. So we choose domain. To find domain we write this is x greater than equal to 0. So how it is greater than equal to 0? That means x square or 4 is greater than equal to this, or x square is less than equal to 4, which imply x lies in minus 2 to 2. So it means this is positive for all x lies in minus 2 to 2. That means domain of fx is minus 2 to 2. So this is the domain. Okay, next question, find the domain and range of fx is equal to minus of mod x. So we already discussed the graph of mod x and the definition of mod x. Mod means positive, so it will convert all the functions, all the values, negative values to positive. What is domain here? So as this is defined for all positive, negative and 0, so domain of this function is set of all real numbers. And what is range here? Now to find range we just have to look at the values that we are getting as output. So if we try to make a small table here, fx is equal to minus mod x. If we are inputting 1, what we are getting? If we are inputting 1, we are getting minus 1. But if we are inputting minus 1, what we are getting? You see, mod of minus 1 is 1, and again minus sign, it is again minus 1. Mod of 2 is 2, mod of minus 2, so mod of minus 2 is 2, again multiplied by minus, it is again minus 2. So this is mod of 2 is minus 2, because it will be multiplied with minus sign. You see, whatever value we input, we will get its negative, and for 0 we will get 0. That means its range is minus infinity to 0. Let us now discuss sum, difference, product and quotient functions. Let f and g be two functions and let df be the domain of f and dg be the domain of g. Then their sum f plus g have domain df intersection dg, and the sum of two functions is defined by f plus g of x is equal to fx plus gx, and for difference of two functions domain is df intersection dg is equal to fx minus gx. Product of two functions is fx into gx. Quotient of two functions f upon g. So, f upon g is defined for the domain df dg except this intersection of these two, except that gx is not 0. So, this f upon g is defined for this domain and this equals fx upon gx. Now, based on these definitions, now we have some numericals. First numerical is we are given fx is equal to x square minus 1, x square minus x minus 1 and gx is 4x minus 7. Question is to find the sum, difference, product and quotient of these functions. But before that we will see what is domain of f. Domain of f is all real numbers. This is defined for all real numbers. What is domain of g? It is again all real numbers. And what is their intersection? df intersection dg is r intersection r, that is again r. That means sum of the two functions is defined for all real numbers. Now, first part, that means f of g of 2 equals f of 2 plus g of 2. So, putting value 2 here, we get 4 minus 2 minus 1 plus 8 minus 7. So, 8 minus 1, 1 cancel, answer is 2. Number 2 part, f minus g of 3, that is f of 3 minus g of 3. So, 3 square 9 minus 3 minus 1 minus 3 4s are 12 plus 7. 9 and 7 16 minus 16, this is 0. 3 f g of minus 1 is equal to f of minus 1 into g of minus 1, that is 1 minus 1 minus 1. So, when we put minus 1, so this will become plus 1 and here minus 4 minus 7. So, this will cancel, minus 11. Now, for fourth part, what is domain of this quotient f upon g? Then the domain is r minus all x such that gx is not 0, which imply 4x minus 7 is not 0, x is not equal to 7 by 4. So, domain is r except 7 by 4. So, this function is defined for this value. So, how much is that then? F upon g of 4 is f of 4 g of 4. and after simplification this is 11 by 9. Next question, again we are given f and g written by this. Question is to find sum, difference, product and the quotient. Now first we write the domain here. What is domain of this function? So domain of function for which function is defined. Square root of a number is defined for positive values. So that means to find domain of f, x plus 4 is greater than equal to 0, and domain of g is x minus 4 is greater than equal to 0. So x greater than equal to minus 4, x greater than equal to 4. Domain of f is minus 4 to infinity, open, and domain of g is 4 to infinity. And for operations, what is their intersection? Minus 4 to infinity, intersection 4 to infinity. So this is 4 to infinity. And for sum, f plus g x is fx plus gx, that is x plus 4 plus x minus 4. For difference, x plus 4 minus x minus 4. For product, x plus 4 into x minus 4, which may further be written as x square minus 16. Now for quotient, domain is df intersection dg except all those x for which gx is not 0. So gx is not 0, that means x minus 4 is not equal to 0, x is not equal to 4. So what will be the domain then? Domain will be here, this is 4 to infinity, that means domain is now open bracket 4 to infinity. And what is this quotient fx upon gx? This will be x plus 4 upon x minus 4. Next question, find domain of the function f defined by this. Now again, domain means all those points for which function is defined. So 2x minus 1 should be strictly greater than 0, and 1 minus x square should be greater than equal to 0. This should be greater than equal to 0, but this should be positive as well as non-zero. So that's why we have written strict inequality here. So simplifying this, so x should be strictly greater than 1 by 2, and here 1 greater than equal to x square, or further x square less than equal to 1, x lies in minus 1 to 1. So what are the common points of these two? So domain, the common points, so that is x lies in this and x is strictly greater than 1 by 2. So they are 1 by 2 to 1. So that's the answer.